Next topic is Jacobians. Suppose U is a function of xy and V is also a function of xy. Right? So here we take x and y as independent variables. Independent variables. So in this case, the determinant, first entry is del u upon del x, then del u upon del y, second del v upon del x, then del v upon del y. So this determinant is called the Jacobian of u and v. The Jacobian of functions u and v with respect to x and y. With respect to x and y. And we denote Jacobian by J. I write like u comma v upon x, y. So I write Jacobian like this, or I can prefer this partial derivative simple. I write del uv upon del xy. Or if the context is clear, then we will simply denote it by J also, right? So this determinant is called the Jacobian. Next, let us suppose that u is a function of three variables as well as v, and next I will take as w. Suppose u is a function of three variables x, y, z. Similarly, v is a function of three variables x, y, z, and w is a function of three variables x, y, z. Then, in this case, the determinant del u upon del x, del u upon del y, and del u upon del z. Next row is del v upon del x, del v upon del y, del v upon del z. Next is del w upon del x, del w upon del y, and del w upon del z. So this determinant is called the Jacobian of u, v, w with respect to x, y, z. So this is called Jacobian of u, v, w with respect to x, y, z. Is it clear? Is it clear to all of you?
Yes, sir.
Now, with Jacobians, there are three important properties which are entangled. So there are three important properties, and we will go one by one with all these three properties. So the first property is if u and v, if u and v are functions of independent variables x and y, are functions of x and y, then in this case, see, del uv upon del xy into del xy upon del uv is equal to 1. So let us denote it by j and let us denote it by z dash. So it says that j into z dash equal to 1. So we have to prove, and it's simple to prove this property. So let's start the proof. See, what is the meaning of this one? Jacobian of uv with respect to x and y. So it is the determinant of del u upon del x, del u upon del y. Then I take the next function v. So del v upon del x, del v upon del y. This determinant multiplied by this. So first I take my first function, so I write del x upon del u, del x upon del v. Then I take the second function, del y upon del u and del y upon del v. Right? So we have to multiply these two determinants. And you know how determinants are multiplied. You know how determinants are multiplied. So once you multiply, see what I am going to get. See, I am going to get del u upon del x, then del x upon del u plus del u upon del y into del y upon del u. Next is del u upon del x upon del v plus del u upon del y and then del y upon del v. Okay. Next, see what is there, del v upon del x into del x upon del v plus del v upon del y into del y upon del v. Sorry, let me check. Del v upon del x upon del u. Sorry, here mistake is there. Uh, this into this del v upon del x upon del u. Sorry, here it is del u, then plus del v upon del y. Okay, next del y upon del u. Here u is there. Okay, and next is again you multiply this with this. So del v upon del x upon del v plus del v upon del y and del y upon del y. So we have this determinant in my hand. So what are those? See, if you look at this, what I am going to get actually? Say del u upon del x upon del u plus del u upon del y upon del u. So it is nothing but del u upon del u, del u upon del u, and here it is nothing but del u upon del v, right? and del v upon del u, del v upon del u, and last del v upon del v. So in this case you can see del u upon del u is 1 and del v upon del v is 1. Remaining these two quantities which are not circled is 0. Because I am differentiating u with respect to v, so it is 0. So I am writing like this, and this determinant has the value 1. This determinant has the value 1. Is it clear to all of you? Is it clear? So let's go to next property, which is chain rule. Next, go to chain rule. See, here if u and v are functions of some variable, which is in turn functions of another variable. So I'm taking intermediate variables as Rs. So if u, v are functions of Rs, functions of
Hello, sir.
R and S. Yeah, please tell me.
Sir, can you go in previous page?
Yes, please.
Okay, sir. Okay. Okay. So just a minute, just sir. Okay, sir.
See, if U, V are functions of Rs, which in turn, which in turn is a function of xy, are functions of x, y. Then in this case, see, whenever I am finding Jacobian of uv with respect to xy, so this is the product of two Jacobians. First, Jacobian of uv with respect to intermediate variable rs multiplied by Jacobian of rs multiplied by Jacobian of xy. So what I will do, see here, I will concentrate here on the left hand side. I will concentrate here on the left hand side and I will find these two Jacobians. I multiply it, it will give the left hand side, right? So it's a very simple. Again, simple steps will enable to reach our goal. So I will start my proof with the right hand side. Del uv upon del rs means Jacobian of uv with respect to rs multiplied by Jacobian of rs Jacobian with respect to xy. So what is first? First one is determinant of del u by del r, del u by del s. Next, del v by del r, del v by del s. Next one, I will concentrate on this one, r. So, del r upon del x, del r upon del y, and then I will choose s. So, del s upon del x, and then del S upon del Y. So I will multiply these two. I will multiply these two and I will check what is this. So first of all, let's multiply what I am going to get. See here, del U upon del R, this into del R upon del X, del R upon del X, plus this into this, del U upon del S, then del S upon del X. Next, I multiply this with this and this with this. So, del U upon del S, sorry, del U upon del R, uh, this with this, into del R upon del Y, into del R upon del Y, plus del U upon del S, into del S upon del Y. Next one, now I will multiply this with this. So multiply, I will write del V upon del R, del upon del X, plus del V upon del S into del S upon del X. Last one, I will multiply this with this. So del V upon del R upon del Y, plus del V upon del S and del S upon del Y. I have to find this. So what is the first one? See, U with respect to R with respect to S, U with respect to S, S. So this is del U by del X. Del U by del X. Next one is del U by del Y. Then bottom del V by del X, del V by del X, and last one del V by del Y. So if you look at this is nothing but the Jacobian of u v with respect to x y, which is the left hand side, which is the left hand side. So this theorem is also proved. Is it okay?
Yes, sir.
You see, I'm also going for Jacobian of implicit functions, right? So I will write only the expressions and then I will come to the problem. Okay. See, if we have a function now which connects u, v, w and x, y, z, x, y, z, right? I have a function f1 which connects u, v, w with x, y, z and x, y, and another function u, v, w, x, y, z, that is equal to 0. F3 u, v, w, x, y, z equal to 0. So if these are three implicit functions, if itna equal to 0, are three implicit functions where see u, v, w are implicit functions of x, y, z, are implicit functions of x, y, z. Then in this case, see, if you are going to find Jacobian of u, v, w with respect to x, y, z, then this is minus 1 to the power 3. This is minus 1 to the power 3. See, Jacobian of f1, f2, f3 with respect to, see, I will write this one here, Jacobian of with respect to x, y, z, whole divided by Jacobian of f1, f2, f3 whole divided by, I will write this thing here, with respect to u, v, w. Similarly, I can reverse the role. I can reverse the role. So when I will write this in the numerator and numerator as a denominator, then I will get del x y, the Jacobian of x y z with respect to u v w. Then in this case I will get Jacobian of f1, f2, f3 with respect to u v w whole divided by Jacobian of f1, f2, f3 whole divided by this thing. So I will get this thing. This is what we call Jacobian or partial differentiation of implicit functions. So I'm going to give the heading as Jacobian or partial differentiation of implicit functions. Implicit functions. Okay. So shall I jump onto the problems now? Shall I jump onto the problems?
Yes, sir.
Okay. So let's try the problems. Question number 1. Calculate the Jacobian of u v w with respect to x, y, z. Where, see, u is defined by x plus 2y plus z, v is defined by x plus 2y plus 3z, and w is defined by 2x plus 3y plus 5z. Okay, so it's simple. See, once you have what I have to calculate, see, I have to calculate del u upon del x, del u upon del y, del u upon del z, and I have to calculate the same for v, del v upon del x, del v upon del y, del v upon del z, and same for w. So del w upon del x, del w upon del y, del w upon del z. Okay, I have to calculate this thing, and this is nothing but the Jacobian of u v w with respect to x, y, z. See, when u is differentiated with respect to x, I will get 1 When it is differentiated with respect to y, I will get 2, then I will get 1. Similarly, v with respect to x, 1, 2, 3, then 2, 3, 5. Okay, I will write this thing. I have to find the value of this determinant. So how we can find C, the easiest method? I multiply all the diagonal elements. 5 to the 10 plus I will multiply super diagonal element along with this 2. So 3 to the 6 into 2, 12 plus I will multiply 1 with this 2, so it is plus 3 minus I will multiply these 3 elements on the other diagonal, 2 to the 4 minus, then 3 3 are 9, and then 5, and then 2 are 10 minus. So let's check how much it is coming. This 10 and this 10 will 12 plus 3 15, 9 plus 9 plus 4 13, 15 minus 13 2. Answer is okay.
Yes, sir.
Is it all right?
Yes, sir.
Okay. So let's go to next question. See, my question is,
Excuse me, sir.
ye- yeah, please tell me.
Sir, could you please go to the last page, sir? I
Huh.
just wanted to see the sum and write it down. Thank you, sir. Okay. Got it, sir.
Yeah, fine. Ah. So if u equal to a cos hyperbolic x into cos y, whereas v equal to a sin hyperbolic x into sin y, then so that del Jacobian of uv with respect to xy equal to 1 by 2 a square cos hyperbolic 2x minus cos 2y. I have to solve this. So what I have to calculate? This quantity. Okay, so del u upon del x, del u upon del y, del v upon del x, del v upon del y. I have to calculate this determinant, and this is nothing but Jacobian of uv with respect to xy. So del u upon del x. This with respect to x. So a cos y, it is constant, and cos hyperbolic x, its differentiation is sin hyperbolic x. So a sin hyperbolic x into cos y. With respect to y, cos y, its differentiation is minus sin y. So I am writing minus a cos hyperbolic x into sin y. Similarly, I go to v with respect to x, a sin hyperbolic x, its differentiation is cos hyperbolic x, and sin y is constant. And then with respect to y, so a sin hyperbolic x I will write, and sin hyperbolic y, and sin y, its differentiation is cos y with respect to. So I have to multiply these two. See, a cos y a cos y and a sine hyperbolic y sine hyperbolic. So all things are square. So a square sine hyperbolic square x into cos square y minus, and this minus will make it plus, then a square cos hyperbolic square x into sine square y. So what you can do here, see, you can take a square common. You can take a square common. So when I take a square common, I am left with sine hyperbolic square x into cos square y plus cos hyperbolic square x into sine square y. So see what I have to prove. Based on this, what I will do, I will break this term cos square y with, right? I will break cos square y. So cos square y is here nothing but 1 minus sine square y, and cos hyperbolic square x is nothing but 1 plus sine hyperbolic square x. So once I will write a square sine hyperbolic square x as it is, and here I write 1 minus sine square y plus cos hyperbolic square, formula is 1 plus sine hyperbolic square x into sine square. So you will do this thing. So what is happening now? See, a square sine square x into 1. Okay. So this term is left. Then a square sine hyperbolic into sine square y. So you can see this is cancelled. This is cancelled because a square is here common. This is cancelled. So only we are left with a square sine hyperbolic square x plus sine square y. But let me check. Your question is in terms of hyperbolic cos. So a square, here I will write cos hyperbolic 2x minus 1 by 2 plus, for this I will write some multiple angle formula 1 minus cos 2y upon 2. So 2 in the denominator can be taken outside. So I have a square by 2 and minus 1 plus 1 getting cancelled. I have cos hyperbolic 2x minus cos 2y. And this is your uh, right hand side. This
Sir,
is
can
your,
you explain that last fourth step once again?
which one? Fourth step.
Uh,
One,
from
two, three, four.
quarter to up. Yes, sir.
This one.
Above. Yes, sir. That how it comes.
See, sine hyperbolic square into 1 sine hyperbolic square x. Right?
Yes, sir.
And then sine hyperbolic into sine square y. Here you have 1
Sine.
sine square y and sine hyperbolic into sine square y. So
Yeah. Okay.
this term will be cancelled with this into this. Right?
Yeah. Okay.
Okay.
Yes, sir.
Yes, sir.
Or you write the complete term and cancel it. Nothing special is here.
Yeah. Okay.
Next question. If x equal to r cos theta and y equal to r sin theta, right? Then find the value of, then find the value of, see, Jacobian of xy with respect to r theta And second thing, Jacobian of r theta with respect to x, y. So first of all, compute this thing. So what is this? Del x upon del r, and then del x upon del theta, and then del y upon del r, and del y upon del theta. So this is nothing but this quantity Jacobian of xy with respect to r theta. So del x by del r, it is cos theta. Cos theta, you can get it from here. Then del x by del theta. Cos theta, its differentiation is minus sine theta. R as it is minus sine theta. Again, I go to this thing. Del y upon del r. So del y upon del r is sine theta. And del y upon del theta. So it is r cos theta. So if you just look it is r cos square theta minus minus plus r sin square theta. If you take r common, it is cos square theta plus sin square theta, and you know cos square theta plus sin square theta is 1, so it is r. Okay. In the same way, you can calculate this quantity, right? So see here, you know, once you calculate this quantity, you know, if you multiply these two, it is coming 1, right? This value is how much? This value is r, so r into this much is 1. So this implies that del r theta upon del xy is 1 upon r. This r you bring to the denominator of other side. So you can directly get its value using your theorem number 1. Using your theorem number 1. Right? And other way, you can also find its, first of all, what you have to do, you have to square and add. So r square equal to x square plus y square. So r is expressed in terms of xy, and similarly you can find by dividing tan theta is y by x, or theta is tan inverse y by x. So you express r in terms of xy, you express theta in terms of xy, and now your work is simple. What you have to calculate? You have to calculate this thing. See, del r upon del x, del r upon del y, del theta upon del x, and del theta upon del y, right? And this is nothing but Jacobian of r theta upon Jacobian of xy. So when you try to calculate this, see, del r by del x, it is 2x, 2x, del r by del y, that is 2y. Then del theta by del x, see, tan inverse is there. So first of all, 1 by x square plus y square minus y upon x square plus y square. And here x upon x square plus y square. You find this. And now you multiply. So 2x square upon x square plus y square minus minus plus, then 2y square upon x square plus y square. Okay, when you take the LCM, right? So, something missing? Uh, let us check what is missing.
Sir, I think mistake is del theta into del theta by del x.
Let us calculate once more.
Sir, in the equation we have r square is equal to x square plus y square.
Yeah,
Should
that is
if
the
I take
mistake.
r, should take
Yes.
roots in this side.
That's why mistake is coming. See, we have r square equal to x square plus y square. Okay. So when you differentiate with respect to x, it is coming 2r, then del r by del x, and that is equal to 2x. So 2 getting cancelled, and you have del r by del x is equal to x by r. Right? So here, this 2 won't appear, x by r will come. This will not come, x by r will come. Now it's fine. Now it's fine. So now it's fine. So x by r, y by r. Now this will not come. So see, it's coming x square upon x square plus y square by r plus minus minus plus y square upon x square plus y square and 1 by r. So now you will get, if I take 1 by r common, you have x square plus y square upon x square plus y square. So it will be cancelled and you will get 1 by r. Okay, so in another case also, you will get 1 by r. Is it all right?
Yes, sir.
Let, let us solve some more problem based on this. See, my question is, if u1 is x2 x3 upon x1, similarly u2 is, you just write x3 x1 upon x2, and u3 is u3, so for x3 I will write bottom, x1 x2. Then you have to find the value of del u1 u2 u3, Jacobian of u1 u2 u3 with respect to x1 x2 x3. Okay, so what you have to do when you have to find the Jacobian of u1 u2 u3 with respect to x1 x2 x3, first of all, what you write? u1 with respect to x1, u1 with respect to x2, u1 with respect to x3. So I differentiate partially with respect to x1 x2 x3. Now I change u1 to u2, so del u2 upon del x1, del u2 upon del x2, del u2 upon del x3. Similarly, del u3 upon del x1, del u3 upon del x2, del u3 upon del x3. I have to find this determinant. This is nothing but this determinant. So with respect to x1. So if you go x2, x3 can be taken outside, common, constant. So x1, 1 by x1, its differentiation is minus 1 by x1 square. So you get x2, x3 common, x1 minus 1 by x1 square. Similarly, if you differentiate it with respect to x2, then x3 by x1, x3 upon x1, and then x2 upon x1. Similarly, I will do it with x1. So x1 means x3 upon x2 minus x3 upon x1 upon x2 square, and then x1 by x2. And in the final, x2 upon x3, x1 upon x3, and minus x1 x2 upon x3 square. So you have to find the value of this. So what you do, you just multiply uh, as we did in the questions where I have found a determinant. So multiply all these terms, multiply this with this, and then multiply this with positive sign. And 3 multiplication, I will multiply this with negative sign, this 2 with this negative sign, and this one with this 2 with negative sign. I will get 4. So it's homework to multiply. You will get 4 as your answer. Okay. Is it all right?
Yes, sir.
Yes, sir.
Yes, sir.
So a varieties of questions can be formed on this. So you are suggested to look onto the book. Please go through it and solve some more problems. And if you have any difficulty, please share it to me. Okay.
Yes, sir.